Hello, and welcome back as we start this new section covering AWS database services. So over here in the Orion papers, let's click on our account and then click down here on databases. Now, one important thing you should know about this database section is we're not going to teach you how to use these various databases. Knowing exactly how to use a SQL or a NoSQL database is not the job of a solutions architect. Your job is to understand what the various offerings are, so when a customer or your organization comes with a requirement for a database, you'll be able to select the right type of database for the requirements of the application, as well as weighing security and cost benefits as well. So in this particular lesson, we're going to start off by talking about RDS, or AWS's relational database service, which is a fully managed SQL database service. So let's click on RDS and then click on RDS Essentials here. So the first thing that you need to understand about RDS is that RDS is a fully managed relational database service. So what that means is that it does not allow access to the underlying operating system. That is what fully managed means, and we will go into a few more key points about that in a few minutes. Also, you connect to the RDS database server in the same way you would connect to a traditional on-premise database instance, for example, using the MySQL command line. RDS has the ability to provision or resize hardware on demand for scaling. So what's important to understand is that RDS runs on instance types, very much in the same way that EC2 runs on instance types. So you have M1 larges, C1 larges, D1s, things like that. So you have all of these various instance sizes, and you can switch between them depending on the type of performance that you need. You can enable multi-AZ deployments for backup and high availability solutions, and we'll talk about multi-AZ standby instances more in a few minutes. You can also utilize read replicas for MySQL, PostgreSQL, and Aurora to help offload hits on your primary database, and we will talk more about that in a minute as well. Relational databases are databases that organize data stored into tables, and the associated tables have defined relationships between them. So what are the databases supported by RDS? Well, currently the list is MySQL, MariaDB, PostgreSQL, Oracle, Microsoft SQL Server, and Aurora. Now, Aurora is a homegrown relational database that has been forked from and fully compatible with MySQL. So this is AWS's own version of MySQL. It has 5 times faster performance than MySQL and a lower price point than commercial databases. So if you're looking to use a traditional MySQL database, I would certainly look at Aurora first. So what are the benefits of running RDS instead of a database on your own instance? Well, the main benefit is that it is fully managed. Well, I already mentioned that being fully managed means that you don't have access to the underlying operating system, but what it also does is it means that AWS is managing the underlying platform for you. So it's going to provide automatic minor updates to your database and to the underlying software. It will also perform automatic backups, which are point-in-time snapshots. You are not required to manage the operating system that the database is running on. You can enable multi-availability standby instances with a single click, and this allows for automatic recovery in the event of failover. And we're going to go into those in more detail in a minute here. So that's just some of the benefits that you need to know about RDS. And one of the key things you just need to walk away from here is that RDS is fully managed and it supports many of the major SQL database platforms that are currently available on the market. So let's X out of here and let's talk a little bit about this diagram here. So we just learned about RDS Essentials. And for this diagram here, I want you to view this RDS instance here as our primary instance. And then we're going to kind of work off of that and talk about various ways that we can use read replicas, standby instances, and automated snapshots to create highly available, scalable, fault-tolerant architecture for our database setup. And the first feature I want to talk about to achieve that goal is multi-AZ failover and standby instances. So let's click on this here. So multi-AZ failover or automatic AZ failover synchronously replicates data to a backup or standby database instance located in another availability zone, but in the same region. So let's just back out of here again and quickly take a look at this. So what is happening here is we have our primary database instance. When we enable multi-AZ failover, which you should do for any kind of production environment. So if you're going to have a production environment in which this database is going to be used, you should enable multi-AZ failover, and it's super easy to do. It's literally just a click of a button when creating the database instance. So what will happen is that anytime that you write data to your primary instance, it is going to synchronously copy that over to a standby instance in another availability zone. So as we know with EC2 instance application architecture, we always want to have multiple EC2 instances running our application in multiple availability zones. This provides for high availability and fault tolerance. So it's the same thing here. This is how we create high availability and fault tolerance within our database architecture, as opposed to the way that we would do it with our EC2 architecture. So in the event of any of these occurring, AWS will automatically switch the CNAME DNS record from the primary instance to the standby instance. So if there's a service outage in the availability zone that our primary instance is in, AWS will just automatically switch the CNAME to the standby instance. So there will be no downtime. It's a seamless switch. This also occurs if the primary database instance fails. It will just switch to the backup. It will just switch to the standby. This can also be used if we want to upgrade or increase the size of the primary database instance. We can just switch the CNAME over to the standby instance while we upgrade the primary instance and then just switch it back. And again, we can do this manually, so we have a manual failover if we decide to initiate that. Also, if we're going to update a software version, again, we can just switch it over and switch it back. So it just creates this seamless failover from the primary to this secondary instance, which is always going to be in a different availability zone. So RDS backups, and we'll talk more about that in a second, are taken against the standby instance to reduce I/O freezes and slow down if multi-AZ is enabled. So we do have the ability to take snapshots, either automated or manually, of our database instance. And one of the great things that we can do is we can set those backups to be taken against the standby instance as opposed to the primary instance. So there is no performance degradation on our primary instance while we're running the backups or snapshots. Now, in order for multi-AZ to work, your primary database instance must be launched into a subnet group. And we'll take a hands-on look at what that means during the RDS lab. However, it is important to note, right, that an EC2 instance must be launched into a subnet, meaning inside of a VPC, just like an EC2 instance. So the same security connectivity rules in terms of network access control list security groups apply, and also the same rules about high availability and fault-tolerant concepts apply. So now, let's go back out to our diagram here. So when we set up our database instance, again, we generally want to always enable multi-AZ failover, especially if it's going to be in a production environment, because it is just going to synchronously replicate all the data here to a standby instance, which we can always just switch over to if we need. Now, what we can always do also is run automated or backup snapshots of our database. So let's click on that and just briefly discuss what this is. So AWS provides automated point-in-time backups against the RDS database instance. So RDS will do this automatically for you, but you can also do it manually as well. So automated backups are deleted once the database instance is deleted and cannot be recovered. So if you're only relying on automated backups and you delete the RDS instance, then those backups are also going to be deleted as well. But you can take your own snapshots of backups before deleting them. So you can have a bunch of backups, and you can just take your own snapshots of those backups and save them for as long as you like. Backups on database engines only work correctly when the database engine is transactional, but do currently work on all supported database types. So all the database types currently supported by RDS are transactional. And it's important to note that MySQL requires InnoDB for reliable backups. So now that we have our highly available and fault-tolerant aspects of this taken care of, including our backups, let's now talk about read replicas. So read replicas are asynchronous copies of the primary database that are used for read-only purposes. So they only allow read connections. When you write new data to the primary database, AWS copies it for you to the read replica. You can create and have multiple read replicas based from one primary database. Read replicas can be created from other read replicas, so no performance hit on the primary database when you want to add read replicas. MySQL, MariaDB, PostgreSQL, and Aurora currently support read replicas, and you can monitor replication lag using CloudWatch. Now, what are the benefits of using read replicas? Well, read replicas allow for all read traffic to be redirected from the primary database to the read replica. This will greatly improve performance on the primary database. Read replicas allow for elasticity in RDS, so you can add more read replicas as demand increases. You can also promote a read replica to a primary instance. So what exactly am I talking about here? Well, let's go back out to our diagram here. Let's say that we have our primary RDS database, and we're running an application which is being accessed by either the application itself or by customers. Now, the application or the customers only need to be able to read from the actual database itself. They just want to pull information. Well, we don't want all of the users and maybe the application itself to constantly be hitting the primary database. So what we can do is we can create 1, 2, 3, 5, 10 read replicas. And what's going to happen is all of the read requests are going to go to the read replica instead of going to the primary database. So this is going to lighten the load on the primary database, but it also allows us to scale out in terms of the amount of read replicas depending on how many customers happen to be hitting the database. So if it's a slow day, maybe we only need 1 read replica. But let's say that we have a huge increase in customers that are hitting the database and are requesting read requests. Well, we can just scale up and have 2, 3, 4, 5 read replicas, just like we use auto scaling for our EC2 web applications. So back into read replica here. It is also important to know that for MySQL, you can replicate for importing or exporting data to RDS, and you can replicate across regions. So what we mean here is that let's say that you have an on-premise MySQL database. Well, you can use RDS to just provide read replicas for your on-premise MySQL server. So now, when should you use read replicas? Well, you should use read replicas for high volume, non-cache database traffic, right? So things that you aren't caching, and say something like Elasticache, which we're going to talk about later on in this section, but for things that are high volume, things that are read heavy, those are the things we want to direct to a read replica. Also, running business functions such as data warehousing, importing, exporting data into RDS, or rebuilding indexes, because we have the ability to promote read replicas to a primary instance. So let's say we need to fix some issues with a current primary instance. Well, we can just create a read replica of that instance. Then we can go about fixing those issues in the read replica so we're not further affecting the primary instance. And then once the read replica has been brought up to the specifications that it needs and the indexes have been rebuilt, then we can just promote the read replica to the primary and the primary to the read replica, right? So we can just switch them and make the read replica our primary and then use that as our primary database. So it's a great way to actually go in and also fix issues with a particular database without further affecting the current primary database in the process. So in summary, what are just some of the key takeaways that we want to know about RDS here? So RDS is a relational database service. It is a fully managed service, meaning that we do not have access to the underlying operating system, but because of that, AWS also handles the management of the underlying operating system and its updates. We do have the ability to enable elasticity, high availability, and fault tolerance for our RDS database through read replicas and multi-AZ failover using standby instances. And at any point, we can decide to access the automated snapshot backups or take our own snapshots if we want to keep them past the lifespan of the actual RDS database itself. And with that, we will conclude this lesson. Thank you for watching. You may now move on.